Hello students, let's start this topic with a simple question. Can you think of ways in which people are connected to each other in your life? You might say, Riya is the sister of Kabir, or Aman scored more marks than Priya, or Aditya and I live in the same neighborhood. These are all examples of relations. In mathematics too, we study such connections not just among people, but among numbers, objects, and elements of sets. In this session, we'll begin our journey into relations and functions by understanding the basic idea of a relation. Let's begin with the word relation itself. In English, the word suggests a link or connection between two objects or individuals. In mathematics, this idea is very similar. A relation connects elements of one set with elements of another set using a specific rule. You can think of it like matching names from one list with names from another based on a condition. This leads us to the formal definition of a relation, which we'll build step by step through an example. Now let's define this idea formally. Given two sets, A and B, the Cartesian product A into B is the set of all possible ordered pairs where the first element is from A and the second is from B. A relation R from A to B is any subset of this Cartesian product A into B. So, we write R is a subset of A into B. If an ordered pair A, B lies in the relation R, we say that A is related to B under relation R, and we write this as ARB. This tells us that A and B satisfy the condition that defines the relation. In real life, we often look for meaning in relationships, like whether two people know each other or are siblings. But in mathematics, a relation doesn't need to have any real-world meaning. We don't always check whether there's a logical connection between the elements. As long as the pair A, B is in the subset R of A into B, the elements are considered related regardless of whether that relation seems meaningful to us or not. Let's begin with the basics. A function is a special kind of relation, one with a strict rule. Every element in set A must be paired with exactly one element in set B, no duplicates. No ambiguity. Now contrast this with a general relation where an element in set A can be linked to multiple elements in set B or sometimes none at all. That's the key difference. Grasping this distinction isn't just academic, it's foundational. Because as we move deeper into the world of mathematics, this concept becomes central to the formal study of functions. Let's quickly summarize what we've learned today. A relation is simply a rule or condition that links elements of one set to another. We define a relation as a subset of the Cartesian product of two sets. And we learned how to write and interpret a relation using real-life examples. In the next session, we'll explore types of relations including empty, universal, reflexive, symmetric, transitive, and equivalence relations.